Today I have another dumpster dive. This is an old piece from a central office that was discarded at work. And I figured I would bring this thing home, tear it apart, and show you guys what's inside, because this is a piece of equipment that the average person never sees. I found this unit in the recycle bin at work. And what this is an old piece of telecommunications equipment that was actually removed from a central office over the last couple months. They actually pulled a bunch of these things out of service because they're all obsolete. These are all OC2 and OC3 based, I believe this one is. Yeah, these are all OC3 cards. And basically, but this particular type of shelf, this was a peripheral shelf that could be used by many different things. If we look underneath here, so this is going to be a teardown video. We'll take a look at this stuff, and then off to the recyclers it goes. But in this unit here, you'll find there's a series of fans, and the air filters and so forth would be in here. These fans are probably useful, as are the power switches here. They could probably be recycled out of this. The rest of it's a lot of scrap metal. But on this here, we had our hub card here, and this would have your optical connection into it. Okay, and here's where your fiber optic would go into this card. Typically one transmit, one receive, so it would have a backup. It would have a main path, so one is in and one is out, and then there would be a backup redundant, and that's what's listed on here, right? TX1 or RX1, TX1, or whether it's RX2, RX1, TX2, and TX1, right? So here's your two transmits. So these have a laser in them that sends a signal out, and these ones here are the receivers. If we look down there, you'll see the difference. If you can see the reflectivity, this is a laser diode, and this one here is a phototransistor. These are the transmitter and receivers for this card. And as you can see, this card was made in Canada. As a lot of this stuff was. I say was because a lot of it now is not. But this old stuff, this was very high-end, very expensive stuff. Of course, that chip comes from the Philippines, as does that one. They still make stuff in Canada, though, and one company that we use at work is called Nebula Technology. They are actually located about a block from where I live, and they produce their products here in Canada for the telecom industry. Here's our receiver modules. Here's the transmitter, Class 1 laser product. So that's one card. Then we've got some OC3 cards here. And again, here's our outputs here and inputs. So I have a transmit and receive. And that comes off of this module here. This is what the fiber termination looks like for in telecommunications, which is totally different than what your toss link you're used to for your home stereo stuff. Right, there's your optical fiber. As you can see, the laser unit itself, this part's made in USA. This is actually an Alcatel board, this one. And this one's also made in Canada. This would be for FPGA chips that we've mounted on this side of the board. So this one here, it has a Vertex FPGA, which is a field programmable gate array. So instead of it having a custom CPU on it, this is a chip that is programmed in the field When it boots up, it's loaded from its internal operating system, and it can be configured as anything, right? Your external circuits on here could have memory as well, so that when it boots up, it will load a program onto here and set this up to whatever the card is desired to do. That cuts down manufacturing costs because they don't have to develop a custom LSI for the application. And maybe we'll take the FPGA off. We'll just heat it up real hot. Heat gun. Should come off fairly easy when I heat it up and melt the solder under it. Yeah, I figured that would have come off a little easier than this. This is a relatively thick board this thing's mounted to. There it is. Along with all the other parts. Thing's gonna be red hot for a few minutes. I better turn it over with some pliers. But there's the underside of the FPGA. As you can see, it's just a standard BGA mount, and this is still molten solder. I had to get that really hot to take that chip off. These things are totally obsolete these days. They have been for years. But when this was current, this was state of the art. This was, you know, all this stuff was state of the art. This whole cabinet here was probably $100,000 at one time. But there's the FPGA off of this one. All these cards just slide into slots on the bottom and the top. It might help if I put it in the right way. You line it up with the slot at the top, and then line it up with the slot at the bottom, and they just simply plug in. And these catches pull it all the way in, lock it in place. That way the maintenance people, if there's a problem with one of the cards, they can just unplug it and plug the next one in. Now this is a little different card. So these ones here, this is a 2MLR, which is the same as that. And this is a 2MIR. This is a 2M MMF. So you can see there's multiple different cards in here. And some of them have got different ports on them. This one's got the fiber port on the front here. We'll pull this one out and take a look at this one. So as you can see, this card has two FPGAs on it. I think those ones are FPGAs. Another power supply down here, because these all operate at 48 volts. That's their central office voltage. So they'll have a DC to DC converter on them to generate 5 volts or 3.3 volts or whatever is required by the specific card. Same as this other one here, also has a DC to DC converter on it. This one, now we have another LC2R, which is the same. Oh, they've got a little reel of fiber in here, a little storage reel. So I guess the fiber runs were a little longer, the patch cords. So they put the excess fiber, they wound it around this little spool. And it's different. The connectors are different, right? So this is a Lucent. But the connectors on this one are different than the others. This one here, I think the fiber, this doesn't have a plug on it, that's what it is. Right, this one's here, the actual fiber is, I believe it's part of the, might unplug. Let's see, does it unplug? Or is it part of the module? I think it's part of the module on this one. This does not come out. Nope, it doesn't. I just broke it. It's okay, because it's going in the recycling bin, but that's the fiber there. And that goes down to the connectors. Of course, the radiation that comes off this is all in the infrared spectrum. So it's not like you can take one of these things and turn it into a laser pointer, because you can't see it. It's all infrared. But the fiber will be wound around this spool here. And on this side, instead of it being a standard push-on connector, this one here is actually a screw-on connector. Actual fiber modules themselves, which you can see they're all hermetically sealed. They have a potting compound in the bottom to keep any moisture out here. If we open this up or scrape off this potting compound, you'll see that there's a little circuit board in the bottom here. This is also going to be a heat transfer type silicone to transfer the heat from the actual laser diode in here back to the board. Because these units themselves are actually quite powerful. You know, they have to be able to send made in Mexico, they have to be able to actually send the optical signal down the fiber, and it can have to go, you know, for 15 or 20 kilometers to where the next terminal is. So the output on these things is actually quite high. See if I can open up the end of this fiber module so we can get a little better look at the laser unit itself, which is right inside here. And here's the little laser block itself. When these modules are made, right, the blue fiber for transmit, the gray fiber for receive, they have an end that's just permanently attached by about 2 feet of cable. And then depending on what type of card it's going on, they don't know where the transmitter receiver is going to be in proximity to the output. So from the manufacturer, they put 2 feet of fiber, and then they just take it and wind it around a spool, because you can't kink fiber too much. So just wind it around a spool to take up the excess slack, and then route this down to the output port, which would then go to the next fiber that's going to next fiber patch that's going to plug into here. Next we have another 2MIR, which is again, this is the same type, but as you can notice on this one actually has a separate daughter board on it, which the first one that I pulled out didn't. This is the first one, right? Oh, is this the first one? No, sorry, I already put it back. The first one didn't have a daughter card though. This is it over here. Yeah, you see this one didn't have a daughter card on it. It goes like that. It's actually a different card as well, because this one's got a couple of FPGAs on this one, but it's got the same type of transmitter receiver that the other one had, right? So this is yet another series of cards with a daughter board on it. This is another 2MIR card, but this one doesn't have a daughter card in it. Doesn't have a daughter board down here. So that gives you an idea that there were a bunch of cards that were, you know, look similar, but they were completely different. Here's an MMF card. Again, here's your optical fibers. And it's got another daughter card here to do additional processing, and a couple of FPGAs. Another LR card, again like the other one. It's got the Lucent laser diode and receiver. What else is in here? Another IR card. same thing. And this one here is just a dummy for when you didn't need a full shelf. You just put a blank card to fill the space. And then the last card here is the secondary hub card, which is going to be the same as the first card that we saw. What this is this passes on to the next shelf. Is it the same as the other one? I believe so. Let me check the other one again. The other hub was up here. We grab it along with all this other crap. And the other hub is, oh, it's different. So the second hub card is a little different. Let's take a little closer look at that one. So both of these are the hub cards. You've got your 2 inputs and 2 outputs. But as you can see, this one's got a totally different chipset on it. Got a bunch of FPGAs, so this one might be the input card, and then this one here could be the output, or vice versa, which is going to now connect to another one of these that are daisy chained together. But anyway, that's what's inside one of these. They say this box itself, these are pretty standard. They use these for ADSL as well, right? At the office that I work out of, there's still a bunch of these things kicking around in the office. They haven't been powered up in years. They've been just sitting there waiting for their day with the wrecking ball, because they'll all be coming out, all going into the recycle bin, just like this one was. A lot of this is for copper technology, which is, of course, on its way out. Everything's going fiber right to the premise these days. So the old stuff, the old T1 lines and so forth, the old single mode fiber is being replaced. A box like this may have been, it could have been used for anything. This could have been used to, you know, each one of these cards here could have fed a cell site, for that matter, right? You know, you'd have your transmit and receive that would go to a full cell site, and everything would go through here. It could be used for anything. But old technology, out with the old and in with the new. This the Main Street Express 36170 peripheral cabinet, which is, or peripheral shelf, as this is called. These were pretty popular because they could have anything in here. They could have OC, OC3, OC2. They could have T1 shelves, T3 shelves, ADSL. This goes back to the ADSL 1 days, the DMT 1 days, but they could have DMT 1, DMT 2, put anything in here they wanted. Very flexible shelf, and they say this box just holds the equipment, but like everything else, it's obsolete now, and it's all being replaced. And I grabbed this one to show you guys what's in it. We'll pull the fan assembly apart on this thing here, take a look at the fans, and then this one is on its way back where it came from, to the recycle bin, as I don't have any space for it, and there's nothing really of any value in here. Perhaps the fans, but that's about it. So if you guys ever wondered what was inside that chip, there it is. That's the silicone, or silicon, I guess. That's the silicon wafer that made up that FPGA. And all those gates that were in there, which aren't anymore because I just let them out. I just opened the floodgate and let all the gates out. Anyway, that's what's inside that chip that now goes back in the box to go back to the recycle bin, because I don't want it. Put the fiber that I took out back in there. See, technically I'm not taking any pieces off this unit because it's not mine. This came out of the recycle bin at work, and I just kind of borrowed it to show you guys what's inside it. And then it's going back where it came from. If you look on the back side of this thing, here's our negative 48 supply and ground, because it runs off 48 volts. The front here is a filter for the fans. can take this plate off and I should be able to get at the fans. Cool. Look at these for fans. They're little blowers. Very nice. They're rated at, what's the voltage on here? Looks like 13 to 52 volts. Made in Germany. These are nice fan units. Maybe we'll take one of these out. See, they've all got filters on them too, so that they don't blow dirty air into the electronics. These things run 24 hours a day, and they make quite a bit of noise too. As you can tell from the type of fan that it is, it's a blower fan. The fan assembly should just, oh look, just slides out. Cool. It's got its own power supply and everything on here for the fans. And looks like each fan is at least a two-phase motor. It's driven by transistors here. Multiple wires going to each motor. So they're going to be a BSL motor. No brushes, so reliability will be very good. Wonder where we put power to this thing. Must pick up power through these. I'm thinking power gets picked up through these. So inside the cabinet here, this is choke filters, right? Power filtering for the DC voltage that comes in on the back here, 48 volts. Two circuits of 48 volts. They both go through filtering, and they both go up to their independent switches. So when this thing's operating, only one of the two switches has to be on, right? You can turn on that one, it'll turn on. You can turn on that one, it'll turn on. Normally they're running with both running. That way, if one of the power supplies goes down, you have redundant power. Because when you're keeping a telephone switching office online, you have to make sure that it stays online. And if you have a failure of one of your power supplies, you don't go offline. That could be a big problem, because these things run 24 hours a day, 365 days a year, and your life could be depending on this equipment, because equipment like this would be used for routing your 911 calls to the 911 center, for example, right? So this equipment has to be reliable, and it has to have redundant power backup. That's why there's 3 fans on here, right? You could lose 2 of these fans up here. You could lose 2 of these fans, and there's still enough airflow to maintain the operation. That's why the fans are installed as they are, right? This is installed like this. So all 3 fans draw air in. Notice that there's a column here which goes into this fan. That's so that the air gets sucked in, because this fan's set back further. Obviously, if we didn't have this column here that goes right into the fan itself, same with the air intakes here. These fit right into the actual rotor here of the fans. So because the air is being blown out, right? When these are spinning, the air is just pressurizing this area up here, which is going to force the air down. But you can have a failure of up to 2 of these fans. If one goes down, we get an alarm, right? If a fan goes down, an alarm is sounded that there's a fan that's down. The same as if the air pressure drops, because there are pressure switches both inside the main cavity as well as up in the top here. So if there's not enough airflow, an alarm will go off and signal the operators that there's a problem with airflow and temperature. But if you lose a fan, or even 2 fans, there's enough airflow from one fan, because everything's in a common cavity here which is sealed, that air from this one fan will blow down through the air filter and go through all of the cards. And that's why you put dummy cards in where there's no actual card in it, in the unit itself. You have to have a dummy card, otherwise the air would just blow out. The air comes out the bottom, down the bottom. It blows down through the unit to cool everything. Anyway, that's going to pretty much wrap it up for this thing. I'm going to put this back together. Put this thing back in my car, like that, and send it on its way back to that big recycling bin in the compound at work when I go back to work tomorrow. Oh well, I'll deal with that. Put the front grill back on. Anyway, thanks for watching. We'll catch you in the next one real soon.